Hello, Matrix, and welcome to it. This is Learn Extra Live with me, AB, and Phil. I hope you're up and ready to learn more with this because there's no more time now to just relax. The time that we have, it is to work more and work hard. Otherwise, we work smart while working hard also. Phil, what are we going over today?
Well, guys, we're getting you ready for the prelims.
Sorry, excuse my manners though. How are you?
I'm great, thanks, and you?
I'm also good. What are we going over today?
Well, we're going to be dealing with some prelim stuff. Guys, if you are in the Eastern Cape, we've actually used your prelim exam that you wrote on Monday, and that's yesterday. We've actually used that as an example, and we're going to turn it into a lesson of how to start revising for your physics and your prelim, and we're going to start dealing with it there. Guys, get on the page, get on the notes.
So this is very important to everybody.
Absolutely, guys. We're going to start out with the next couple of weeks are all about revision for your prelims and for your finals. And we just got a couple of days left, guys.
Well, there's no more time, man. So let me tell you and not waste your time. Join us on Facebook, on facebook.com/learnextra. Like the page, share the page, tell your friends about the page, help other mindsetters on the page, and ask your questions over the page. Secondly, get also your fast notes link on that same page. Otherwise, you can also follow us on Twitter @learnextra. But otherwise, a big thank you to Macmillan for proudly sponsoring this show and making sure that you have your notes that you can download and use for free. You can access them on learnextra.co.za/live. But for now, let the learning begin.
Absolutely, guys. Now, guys, I've received a lot of complaints from guys who have just come out of their exams and they're like, oh, I studied so hard and the exam was so difficult. They asked the question in such a strange way and I was not prepared. Okay, now guys, that is probably the number one complaint I hear from people who have studied hard and they come out of their exams and they're really not sure what's going on. So guys, I'm hoping some of the advice that I give you today on how to prepare and what to prepare on, and even some of the questions that we're going to be dealing with a little bit later on are going to help you out prepare for your prelim exams. Because as Ebi says, the time is short, guys. Let's make the most of our time together and let's make sure that we're actually getting down to using our time effectively. Guys, we're going to be working smart and hard together. So guys, please just make sure that you take some of this advice into hand, because a lot of you say, okay, well, I'm going to study. Study how, guys? A lot of you don't have the correct study skills to deal with physics and chemistry, and they're actually different from each other. So hopefully I'm going to give you some advice today on how to approach each one of those exams and actually start to see how to do this. So let's take a look at the menu for today. Now, it's very, very short today. It's very, very simple, and we're actually just going to divide the lesson up into two basic parts. Okay, now this very first part, what I'm going to be doing for you, and guys, this is all in the notes on the page, guys, and Abi's going to be posting them the whole way through the lesson, and he's going to jump into those notes and start posting bits and pieces out of those notes. Guys, it's all about learning how to study, and guys, I've put in a little mind map there on how to actually study and the exam breakdown. So there we go. We're going to be taking some tips on how to study for the exams, and we're going to be tackling some prelim examination questions. And I'm going to be showing you just how difficult it is when you get thrown in a situation with all sorts of different questions. And that's what we're going to do today. We're going to use that Eastern Cape Paper 1 as an example of how to jumble up questions. And we're going to start taking your exam approach. And I think one of the first flow diagrams which I've actually shown you is how to actually approach your studies and where to spend your time. So that's actually where I'm going to start my lesson today. Now you might say, okay, how do I begin to study for science? Okay, well, let me just show you the typical sort of approach of a grade 12. So the first thing which you decide to do is you make a summary. So you summarize and you make this beautiful summary, and I see lots of like sort of mind maps all over the place, and I see beautifully written notes, and you think, oh, well, I'm spending all this time making these beautiful summaries. But guys, a lot of you actually get stuck at this stage. You make these beautiful summaries, and just writing stuff out on the page doesn't mean an A in your exam. Okay, some of you go a little bit further and you say, no, I've got this waxed. I'm going to summarize this chapter and then I'm going to go and practice my exercises. Okay, so you're saying, okay, all right, no problem. I'm going to make my exercises at the back of the chapter, and exercises are all there, no problem. So I go from summary to exercise, and you say, I practiced my photoelectric effect. I did all the questions on the photoelectric effect. Now, guys, I'm going to tell you that these two should be around about 10% of the time that you spend on science. A lot of you are actually wasting your time by spending way too long making these beautiful summaries and just practicing exercises. This is the last key. This is the essential ingredient. And if you look inside those notes, I've actually posted links to some of the Tutong websites and the government education website. Guys, get the past papers. This is where you make or break your attempts. Guys, getting into those past papers will do many good things for you. Let me just tell you the advantages of the past papers. And you might say, what is the difference between doing past papers and just doing exercises? Guys, your past papers, this is where you should be spending, and I'm not kidding, 90% of your time should be spent on past papers, especially with physics. Now, guys, you might say, well, why? No, I've got to learn all my definitions. I've got to learn all my summaries. Guys, I'm going to tell you that like maybe 5%, and then 90% here. Guys, so you spend one afternoon, quickly make your summary. Guys, don't try and memorize your summary. Please don't do that. You've already done all the hard work. You've made your summary. Now, I want you to take your summary and sit and do the exercises. Great, you finished off your exercises. Now, please don't spend all your time in those first two steps. Actually sit with your past papers. Now, let me tell you why past papers are beautiful things to do. Now, beautiful because here's your advantages. Okay, number one, the questions are mixed. So you get mixed questions. Now, mixed question, you might say, well, what's the purpose of mixed questions? Now, I see a lot of complaints from maths as well. Here's the problem that exercises give you. When you're practicing your exercises up at the top here, your exercises say, okay, well, I'm doing photoelectric effect. By the time you reach those exercises, you're going to go, oh, I know exactly which equation to use, I know exactly which formula to use, and you use that formula 20 times, and you think, oh, I've got that waxed, it's no problem. See, the problem is in an exam, they won't tell you when to use your formulas. It'll be all jumbled up. So mixed questions are really important. And this is another big thing, is by the time you get into an exam, a lot of the stuff will be familiar. So familiarity is really important when you walk into that final. It's not the first time that you've seen these types of questions, and you know how to cope with new questions very quickly. And this is my favorite part of why past papers are the biggest thing and the biggest amount of time, is that they condense your study time. They prioritize. Now, you might say, okay, well, what does it mean to prioritize? It means that you start to understand which questions are important, and this is the really important part. If you're sitting doing your past papers with your summaries by your side, what you will find is that the stuff that you don't know from your past papers, you can just quickly look inside your summary for that tiny piece. Guys, past papers give you focus. If you're constantly being asked questions, you're constantly recalling, and that's the way to build memory. Constant recall is the way to build long-term memory. Okay, now what I've done, and we're going to be posting similar summaries like this for your physics, but now for those of you that are still studying for some chemistry prelims, I'm just going to give you a little bit of a heads up. Things have changed very, very slightly in terms of your chemistry papers. Now, I'm going to be posting a similar page like this for your physics later on. I just want to give you a heads up for paper 2 here. Now, this is what you should be doing, is you should be taking a look at the broad overview, and we're going to mind map this out later, and then chop it up into smaller pieces. So that's what I've done for the chemistry paper. Okay, now matter and materials, which is your organic. Guys, this is almost 35% if you include all the reactions and all the multiple choice and all of that. Now that might vary by 5 or 10%, but it depends on paper to paper. Now here is where the money actually is. Chemical change. Now, chemical change is actually the section that people don't like at all. Chemical change is the section that people get 1 or 2 of these things and they're kind of like scared of it. But guys, chemical change, I'm going to tell you now that chemical change is where you should be starting your study. Chemical change is the basis for chemical systems, because these two make up the majority of your paper 2. When you start thinking like this, your exam preparation becomes a lot smarter. Okay, so now I'm going to leave it up to AB to post up all of these breakdowns of the chem and the physics. I'm just using a chemistry paper as an example of how to do this. Break it down into papers and prioritize your studying. So I'm going to tell you now, chemical change is the most important section because it's got rates and equilibrium, and it's got redox inside there. These are the basis for your chemical systems like batteries or chloralkali, which only looks like 20%, but guys, it depends on your chemical change. So get in there and start with that. A lot of people just start with the stuff, I like organic a little bit more, so I'm going to start with organic. Guys, You're wasting your time. The prelims are here, your finals are here in a month or a little bit more than a month, and guys, you've got to make sure that your time counts the most. So be smarter, not instead of don't worry about this, I'll just do lots of organic and organic will be fine and I can guarantee my 35%. No, guys, tackle the stuff that you're not good at, ask your friends, get on the page, ask us, and then we can help you out. But without further ado, what I'm actually going to do is I'm going to jump straight into prelim questions. I'm just going to show you how mixed up things can actually be. Now, what you should be doing when you climb into a prelim like this one, and we've posted up a whole bunch of stuff inside our notes, you guys should be tackling this with us. Now, we're going to take a short ad break in a moment, but what I'm going to do is I'm going to give you guys a little bit of a challenge to start with question 1, and we're going to start to deal with some of the SI terminology which goes into this, or some of the terminology which we start to do. I like the short questions in this prelim paper for this reason. They're a complete jumbled up section, and it's a complete soup of all of the questions that I could find in paper 1. So guys, it's got some mechanics, it's got some matter and materials, it's got some wave, sound, and light. It's even got the electricity and magnetism, and those are the 4 sections inside the physics prelim. Now, what we're going to do is we're going to encounter all of those. Now, before we go away on our ad break, I'm going to give you a chance to try and discuss these first 5 answers. Okay, so now this is question 1 from the Eastern Cape prelim paper 1. So guys in the Eastern Cape, you should be taking a look at this and going, oh, yay, or oh, no, there's something I can work on. So let's go through these questions. We are looking for the one word or term for each one of the following. Write down only the word or term next to the question number. So we've got 1.1 through to 1.5. Okay, so let's start off with the first questions. Guys, I want you answering on the page and dealing with some of these answers. Try and post all of your answers together to try and see if you can start to deal with this. You'll notice that these are all from different sections. So this is why I really like the short questions. Here it goes. In 1.1, it says the SI unit of the quantity calculated by the product of force and velocity. Now, guys, you should be looking for keywords here, and force and velocity are there, and it's a product of force and velocity. So there's a little bit of a key. Force and velocity fall under mechanics. Okay, now, question 1.2. This gets into electricity and magnetism. It says the electrical potential energy, so electrical potential energy per unit charge. Oh, that's kind of difficult, guys. Electrical energy per unit charge. So that's 1.2. 1.3 is the ability of a wave, there's a keyword, the ability of a wave to spread out in wave fronts and thus bending around a sharp edge. Around a sharp edge. Okay, so wave, sound, and light. You can see that we've actually gone through most of physics already. The spectrum that is produced when cooler vapor absorbs light of certain frequencies. Guys, that's particularly challenging. Now, we know that that's got something to either do with matter and materials or wave, sound, and light. And then very often, the next question, 1.5, says that the phenomenon that explains why electrons are emitted. When light shines on it. Okay, and that's really important, guys. So what I want you to do is when you tackle questions like this, identify which section you're dealing with, try and identify the keywords that might give you some clues, and I want you to work on this. Guys, I actually want you during the break to be posting all of your stuff on the page and discussing what's going on here. Form yourself a study group, practice the questions, guys, because from this already I've covered my entire physics syllabus. And this is the way to do it, guys. Get into the questions before you spend all of your time on that theory. Are there some answers starting to trickle through there, Abby?
I hope I think they're still downloading the questions.
Okay, no, well, that's good news. Okay, so guys, if you're getting onto the page, get onto the notes and start to answer some of the questions. I think it's been posted as some pictures on the page.
Yes.
And then you can start slotting in your answers underneath there. Discuss. If you don't agree with somebody, discuss, and that's how we learn, because that'll trigger your long-term memory, and then you don't have to relearn the stuff for finals. Guys, lay down the good groundwork now for your prelims.
Thank
But I
you
think
so
it's time for a break, eh?
It is the time. Otherwise, a big shout out to all the mindsetters that are watching and solve our mindsetter of the month. And also, Mosa, I wonder where have you been? Because I last saw you on the After Earth competition. So after that competition, you just finished. But welcome back. You came back at the right time where we're still doing some questions that are very much important to everybody. Otherwise, mindsetters, be on the page. Let us know you're enjoying the show. If you're having any questions, we'll see you after the break. Welcome back, Mindsetters. Now, good news for you matriculants. We are having a spring school, which is starting from the 23rd to the 27th. These are the dates that you need to diarize and make sure that you keep an alarm and be alert of 23rd to the 27th. We're having a spring school just for you where we'll be treating some special exam questions and we'll be having live shows that are there to help you. Otherwise, we'll be learning with you on Facebook. Also, you will get a chance to post some questions, ask some questions, and we'll be there to reply and help you. And on top of that, here's a cherry. We'll be posting some exam questions throughout. We've started yesterday, so we'll be giving you some exam tips over the time as you are studying and preparing for exams. Here's a quick tip that we have for you for now. Always stick to your study schedule. We know that most of you have a study timetable or schedule that you have. Stick to it. If you said you're going to study maths, let it be maths. Do not get anything distract you. Phil?
Absolutely, guys. Stick to your timetable. Right? Failing to plan is planning to fail.
Exactly.
Okay, so guys, you've got to put down that plan, put it on paper, stick to your time. Now, all that we're trying to do today is to try and make use of that time in the best way possible. So guys, this is golden advice. Make sure that you are starting to practice a mixture of questions. So we're assuming that you've done some summaries already. Okay, it's already prelims. You're sitting there with your summaries. You're sitting there with your definitions. And now you're kind of like, well, do I memorize my summaries? No, guys. We're not going to ask you a question. Please just, revise all your summaries and give them to us on a page. That's not how a science exam works. A science exam uses questions, and what we've done is we've posted some questions. So guys, if you were working on some of these questions before we went away on a break, I want you to mark yourself, check yourself, and we're going to start dealing with the thought process that you would need. Okay, so now we're dealing with question 1.1. It said, the SI unit of the quantity calculated by the product. Now, product means multiplication of force and velocity. So now, if I was really stuck, all I would have to do is multiply those two together. Now, you might say, okay, now, F times V, F times V. Oh, wait a minute. If I go look on my formula sheet, I see that F times V is equal to P for power. But now, read the question very carefully. They would like not P for power, they want the SI unit. They want the standard unit for power. So power is measured in watts. So we are looking for watts over there. Watts is the correct answer for this. So if you guys got that correct, I'm very, very happy. That means that you did your work, energy, and power as part of your mechanics. So I'm very, very glad if you got that as a final unit. Okay, so let's move on to our next question. It says the electrical potential energy per unit of charge. Oof. Now this one's a little bit more obscure. It's a little bit strange. It says the electrical potential energy per unit of charge. Now electrical potential energy is to do with joules. Now it says per, so it's joules per. What is per unit charge? Well, I measure charge in coulombs. Joules per coulomb, joules per coulomb. Okay, that's a little bit strange. Now we're looking for the term which describes joules per coulomb, or work divided by charge. So if I make a formula of work divided by charge, wait a minute, there is a formula I know that's work over charge. Look on your formula sheet, think back to grade 10, energy per unit charge. Guys, that is a measure of voltage. Okay, so there we go. So it's volts or voltage. So the volts over there. Now this one, they're not looking for the SI unit, they are looking for the volts or the voltage. So electrical potential energy per unit charge is a measure of your voltage. Notice how they're using formula, they're testing your definitions all in one. Now, John has given me some amazing advice to pass on to you guys. You might notice that this is taking a really long time, and each one of these questions is only giving me 1 mark. Now, let's say that this is your prelim exam. Guys, you're under pressure and you're saying, oh, question 1. This is taking me forever for each one of these marks. And that's absolutely true, guys. So you guys can play smart even inside your exams. What I want you to do, if you are somebody that really struggles to finish exams and time is not on your side and you're not feeling that confident, guys, you can skip out question 1 and come back to it much later. And that's actually a really smart thing to do. You'll notice that these things are only giving you 1 mark for a long process. So, guys, I want you to skip past this and come back to it. It doesn't matter which order you do your questions is. Just one tip is to always label your questions very carefully. Make sure that you've got question 1 at the top of your page and you've shown all your correctly numbered answers. Your examiners need to be able to find all of those questions. Doesn't matter which order you did them in. So my tip is to start with the one that you are the most confident at. So you say, I'm really good at electrical circuits, so start with that question first. Get your marks. Go to the other ones and spend your time there. So the likelihood is that you've spent your fresh brain energy on something that you're guaranteeing your marks. Now you can start to tackle the more difficult things.
I fully agree with you, Phil.
Absolutely.
Because shockingly, I have statistics here, like over the 30 comments that I have so far,
Yes.
and no one got 1.1 right.
Oh, well, there we go. And that was a long process for just one mark.
Some said watts and some said power.
Okay, watts is correct, power is not. They didn't follow
But
the
the way
question.
is it also right, because the question was saying you're looking for the SI unit.
So we're just looking for the unit. So we're looking for W or watts.
Okay.
Okay, so that's all that is acceptable. But guys, power is not. I haven't read the question. But I've gone through this long process and I've wasted all this time just for 1 mark. But the reason that I like these questions for tonight is because they're great for practice. Question 1, the short questions are really great for practice. And guys, if you've been following us over the last few weeks, those curio questions are really good mixed up practice. They're mixed up examples. And over the next couple of weeks, we're going to be firing lots of questions. As AB says, just mixed questions. That is where you really understand if your summaries make sense. And if you identify something, you can quickly go back to your summaries, take a short piece, and come back. So guys, you've got to be smart about how you study, because I want you guys prepared. I want a lot of A's. I want you guys to write us these beautiful long letters at the end of the year. You say, thanks, Mindsetters. Thanks, Learn Extra. We did amazingly. And this is one of those tricks. Start with the questions that you're confident at, but use your mixed questions to practice with first. So here we go. We're carrying on our practice over here. So over there, I've got my watts over there. Now, what am I going to do? Now, question 1.3. Now, we're looking for a term, or we're looking for a single thing. So 1.3, this is what our next answer is going to be. So 1.3 says the ability of a wave to spread out in wavefronts and thus bending around a sharp edge. Okay, now I want you to picture what's actually going around. So now, if you need to, you can draw yourself a picture. So if I've got a barrier, now here's my barrier over here, and if we start to picture what's going on here. Now they said that wavefronts are going to be approaching this barrier and spreading out. So as these wavefronts approach, what I notice is when they get on the other side, I start to get these curved wavefronts. Now guys, that curving of waves around the barrier, so they initially moved in a straight line, but now are changing directions and spreading out. This process is called diffraction. Not refraction, not reflection, but diffraction. So how are the guys doing on the page there? Are they getting this correct for 1.3?
1.3.
So diffraction, how's it looking?
So far, so good.
Oh, very nice. So these guys know their waves sound alike.
Yeah.
So this is nice. We're hopping from one section to the next to the next. Okay, so question 1.4, let's put a little bit of a challenge to them. It says the spectrum that is produced. Now this is a really difficult one. When cooler vapor, so cold gas, absorbs light of certain frequencies. So some frequencies will be missing from the spectrum. Okay, so we've got a couple of options. Now there's only really 3 types of spectra that we can discuss. The first one is a continuous spectrum. Okay, now a continuous spectrum is the complete rainbow of light. Okay, now there's two other different types. There is an emission spectrum or an absorption spectrum. Now, an absorption spectrum is the one that we're after. And I'm going to discuss these other two first. A continuous spectrum is a clean, all the way through all of the wavelengths, so it can't be that one. An emission spectrum uses hot gas and gives out only certain frequencies, so you'll only see some colored lines. So it's not an emission spectrum. An absorption spectrum, and I'm hoping the guys get it on the page there, an absorption spectrum is the one which has got all the colors but a few missing lines. So absorption spectrum is my correct answer over there. So now, oh guys, you got a bit of studying to do in your math and materials.
No, I'm getting electromagnetic.
No, guys. Okay, now all of these are examples of electromagnetic spectra. Every single one of these is a type of electromagnetic spectrum. Continuous is my visible spectrum. Now, emission is only certain parts are colored. But the absorption spectrum is the one with the missing lines, the dark bands. Guys, you've got to get onto this. All of these are types of EM spectra. Now, spectrum just means a collection of different wavelengths or a variety of them. So guys, you've got to know what the difference between a continuous, an emission, and an absorption spectrum is. So maybe this is something that I need to discuss a little bit later with you. What does a continuous, an absorption, and an emission spectrum? Maybe Abby can post some onto the page and we can start to see where you guys are struggling. These three, very often, their pictures are put next to each other. So if you do a quick Google image search on this, guys, you'll actually find a continuous, an emission, and an absorption spectrum all together in one image. The continuous spectrum will look like a rainbow. An emission one will be dark with a few colored lines, and then an absorption spectrum will be a continuous rainbow, but there's some missing pieces, some dark lines in between there. So they're all different types of EM or electromagnetic spectra. So guys, if you did manage to get absorption spectrum, that is the correct spectrum which is being shown over there. Then, for our very last one, I really love this one. It says, the phenomenon which explains why electrons are emitted or given off from a metal when light shines on it. So that's 1.5, and that's my very last one. Guys, we've done this one, and we've discussed this one this year. So think about this. Electrons are coming away from a metal surface when light is shining on them. So I'm thinking of this process, light shines down on my surface over here, and somehow that light is giving energy to those electrons to allow them to escape. What I've just described, and this can't be described any other way, is a really good example of the photoelectric effect. And that is the very last short answer over here. So for 1.5, now we've jumped around quite a bit here. So that is an example of the photoelectric effect. And there is no other possible answer here. The photoelectric effect. How have the guys answered that on the page there, Abby?
Yes, they got it.
Very nice. Okay, guys, so you're most of the way there. We've just got to refine what you're doing with your spectra, and I'm glad to see that you guys are sharing on the page, studying your way through these. Again, just with that advice, make sure that you're practicing mixed up questions so that you don't get used to one formula or one method. I'm just going to run you through some of the thought processes I did. When I read these questions, I'm looking for my keywords, and I want you to do this in an exam as well. Sit there with a highlighter or a colored pen and start to look at the meaning of this. I noticed a lot of you really struggled with 1.1. Now, a lot of you said power. Okay, so you followed the advice and you managed to get most of the way there, and you guys actually summarized correctly. You said that force times velocity is equal to power, and that is correct. But guys, doesn't help if you know the knowledge if you're not answering the question. The SI unit, they want the units of power, and that was watts. So W or watts would have been the acceptable answer there. And the other one, which really, this kind of floored me initially when I read through it. I went, whoa, okay, how am I going to answer this? Now, highlight the keywords. Electrical potential energy. Now, us examiners, we're a little bit cheeky. What we like to do is we like to hide simple words in very complicated words. So electrical potential energy, guys, that's work. It's electrical work, so it's just W, which is measured in joules. Per unit charge, now I've got to think about my units of charge. It's coulomb, so it's joules per coulomb. Guys, that is the definition for 1 volt. So I hope you've kind of identified with some of the thought processes that we're doing. But guys, just because these are great for practice doesn't mean you have to start at the section in your exams. In fact, this has taken us so long just for 5 marks, guys. You should be working on just a little bit over a mark a minute. And we've spent almost 15 on 5 marks. Now that's unfair to you, and you're not going to use your time very wisely. But when you start, you get your exam and you've got your reading time, read through these. And something amazing happens inside your mind when you do reading time. Don't just flip through your paper and say, I'll do that, do that. Actually read through the questions, and you'll be amazed at what your subconscious mind does with that question in the meantime. What your brain will start doing is it'll start waking up all those old memories, just like a pilot sitting at the switchboard. And it'll start waking up those memories as you get into that exam. This is one of the techniques that I used to get my degree. As I read through those questions, even didn't give them too much thought, but it starts to wake up those memories from deep inside your memories. Guys, we're going to take a short ad break, and then we're going to get into those multiple choice questions.
Right, I hope you're ready for them. Otherwise, Mindsetters, let me also take this time and tell you about the Stars in Education. You can nominate a teacher that you think they deserve to be awarded, acknowledged, and to be appreciated. More information will be posted on the Facebook page, and the link on where can you get the application form. Remember, the closing date is the 7th of September, this coming Friday. More details on facebook.com/learnextra. We'll see you after the break. Welcome back, Matrix. Now, here's that fast link for you to apply. The application form can be found on www.ed.org.za/teachers. Look for the application form there to nominate your teacher for the Stars in Education Awards. Otherwise, back to you, Phil.
Thanks so much. Okay, guys, so nominate those teachers. Those teachers want to be recognized. Jump on that fast link. I'm sure that Avi's already posted it. Guys, you've got to be working on the Facebook page with us because it's the only way really to watch the show. Guys, get on there on your phone, on your tablet, your PC, whatever. Get on the Facebook page. It's the best way to share. Okay, so now what we're going to do is we're going to jump into some multiple choice questions. Now, some of my matrics just call this, it's the multiple guess section. But guys, no, you've got to play this smart. Now, here's my problem with multiple choice questions. This, I think, is actually the toughest part of your entire exam. Now, the reason I say this is because there's a lot of thinking, and examiners are trying to see if you really understand. Now, they've designed all 4 options over here to sound correct. So they're trying to catch out those people that kind of summarized and didn't really prepare and didn't practice enough questions, and they're trying to catch you out. Now, it's not because they're nasty. What they want to do is they really want to understand if you are precise, if you are accurate in your understanding. Now, I do exactly the same thing to my grade 12s. I always provide answers which are sounding kind of correct, and only if you are absolutely good at that particular section can you find the correct answer. But there's a few tricks along the way. So what I'm going to do is I'm going to sort my way through this. So let's read the question together. Now, I've got 4 options which are available. Okay, and now I've just got to answer A through to D. Now, please don't just go and dive in there and pick A, B, C, or D, because what I want you to do is to consider all of them, try and eliminate as many as possible, and then pick your answers. So this is the way to play this smart. Okay, so now, please, another thing which I've seen in marking several times before now, is that people are not answering this correctly. What they do is that they say, no, I think that B is a correct answer or A is a correct answer. And they begin to say 2.1 in their answer page, and they actually start writing this out. Guys, please follow your instructions. If your marker cannot find your correct answer over here, follow it. There's an answer sheet where you can put a cross over the A, the B, the C, or the D. Please read the instruction. This is why we taught you to read, is so that you can find the instructions and find the information. So there we go. Question 2.1. It says, when a projectile is moving vertically upwards. Okay, so now a projectile is any object which is subject to gravity, is moving vertically upwards. Okay, now a whole bunch of things start to happen when we move an object upwards. Okay, so now anytime I draw a mechanics question, now if you were watching a little bit earlier on, so matrics, you should be watching some of the grade 10 shows as well. There's good revision in there. I was telling the grade 10s that it's always good to talk about a positive direction, have myself a diagram. I know what happens to moving objects. Right, my moving object goes up, 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 and then eventually comes back downwards. The reason that it does that is because it's got an upward velocity initially. It stops up at the top, and it comes back down. So now I've got a picture inside my head. Now let's get into the answers. Okay, option A. It says it has 0 acceleration. That doesn't sound right. Why is this statement incorrect? Now I've got to say, okay, that doesn't sound right, but why? It does have acceleration. It is accelerating downwards. Now you might say, no, wait a minute. It said it's thrown upwards. Philip, I don't believe you. It's thrown vertically upwards. Ah. Now that means that it has an upward velocity. So it is moving upwards. How can I then say that the acceleration is downwards? Now guys, if you studied your Newton 2 correctly, you'll know that acceleration is because of force. The only force which is acting on a vertically moving projectile is gravity. And gravity, guys, is down. So therefore, acceleration is down as well. So there is an acceleration. Gravity acts on all projectiles. I don't think option A is correct. What about option B? It says accelerates downwards with a constant acceleration. Now that doesn't sound right either. But is there a problem in my thinking or how it sounds? Accelerates downwards. But guys, I know that objects which move vertically all accelerate downwards, whether or not they are moving up or down. Now, I want you guys, if that's confusing you, get on the page and discuss with each other. How can something which is being moved upwards be accelerating downwards with a constant acceleration? There's a trick here, guys. That acceleration is due to gravity. Now, I think option B is actually correct. Right, now we'll come back and see if that's actually correct. Now, C loses its mass. Okay, now, I don't know about you, but most projectiles which I throw up come back down with exactly the same mass. Now, the mass is the matter which is inside that object. Now, guys, our object did not go on a diet. It didn't lose a mass. It didn't exercise on the way up. It's impossible for most objects to lose mass unless they fall to pieces. Okay. Now, it says, has its maximum velocity at its highest point. Well, let's look at our picture. Is there a maximum velocity up here? No. Guys, the smallest velocity is at its highest point. That is where velocity becomes 0 and it turns around. So option D is absolutely incorrect. See how we've convinced ourselves that B is definitely the correct answer. And guys, this is the way that you should be doing this. Eliminate the other answers. You might be left with 2 to choose from. I thought that B was correct. I'm now sure that B is correct because I've wiped out all the competition. I now know that 2.1 is question, and the 2.1 question's answer is answer B. So I need to eliminate all the competition and see where to go from there. Okay, so now this is kind of a weird thing. How can something be accelerating downwards? Well, guys, because acceleration is due to gravity. Gravity is always downwards, and Newton 2 says that if a force, a resultant force, is applied to an object, an acceleration will result in the same direction as a force. Now, gravity is down, so acceleration is down, even when the object travels up. That's why it stops. Acceleration and velocity are in opposite direction, so your acceleration will stop, your velocity will become 0 velocity. So guys, discuss it on the page, sort it out between yourselves. If you're still struggling, ask us. Send us some email, and we'll try and answer your questions.
I think that's quite a challenging one because I think 50% was saying D and B.
Okay, well, there we go, D and B. Now, a lot of people were really struggling with this. Now, this is the thing. In an exam, all of these are going to kind of sound correct, and this is why we're getting such a mixture of answers. But in the end, it's only B which prevailed. Now, it was kind of difficult to be able to tell this, but guys, it relied on having a good picture of what was going on. This is why multiple choice is so sneaky. It tests an entire section but only for 2 marks.
It's
So
not
make-
just guesswork after all.
Absolutely, you can't
It's
guess this,
logic.
guys.
Mm.
You've got to use your logic as you work through this. Eliminate the wrong answers, and you'll be left with 1 or 2, and then you can choose, and that improves your chances. Even if you have to take a little bit of a risk on the guess at the end, at least your chances will be improved by eliminating the bad ones. So guys, don't just make patterns on your multiple choice question. I know some of you are just going, oh, it's a multiple guess, and you just go like A, B, C, D, E. Okay, right, and you're just making patterns on your answer sheet. Please don't do that.
I'm actually laughing at this comment from Musa. He says, Phil, though, our object didn't go for a diet, it can't lose its mass.
Absolutely, it's impossible that the object's got it, like, it comes back down and it's looking beautiful with a beach body at the end. No. The object can't do that. It can't lose its mass on the way down. So sometimes you'll find a completely silly answer and you can cross that out immediately.
Yeah.
Very good. Okay, so let's climb more into our multiple choice question. Okay, now for the guys who downloaded the notes, it's a bit of a treat. I've already drawn the diagram in for you.
And
Okay.
it's posted.
It's posted, guys. There's a picture there. So now I've got a goods train A traveling at a velocity of 11 meters per second east. So what I'm going to do now is I'm going to draw out these 2 objects. So now I've got 2 goods trains. So let's draw one set of tracks up at the top. So there's my east line. And then on the adjacent set of tracks, I've got another train which is heading in the opposite direction. Okay. So now what I've got is these 2 trains which are going out there. And for those of you that have downloaded the notes, you've got a bit of a bonus. I've already drawn this in for you. So here's my one goods train. It is now traveling in this direction at 11 meters per second, east. So here's east, and there is west. Okay, so it's traveling at the other one is traveling at 23 meters per second west. So here's my other goods train, which is coming through here. So here's my second goods train, which is now traveling at 23 meters per second in the opposite direction west on adjacent tracks as shown in the sketch below. Now, we've got these 2 objects headed in opposite directions towards each other. 11 meters per second towards the east, which is goods train A. Then goods train B is heading from the opposite direction, as shown in the sketch below. So we've made a sketch for ourselves. Now it says the magnitude and direction of the velocity of goods train A. So we're looking for the velocity of train A relative to B. Okay, now this one we can do by logic, but I'm going to show you the long method of doing this. Then we'll go back to the short. Always the long method first. So now what we've been given is we've been given a vector diagram with 3 different velocities. It might not look like it, but one thing which I know is that I've got train A, train B, and I also have the ground. Okay, so now there's actually 3 objects, and the ground is not moving. Now, you might say relative to other objects. Yes, that's correct. The ground is actually moving under your feet. Okay, the entire Earth is moving, but I'm going to consider the ground to be at 0 velocity. Now what I've been given is I've been given velocity of A relative to the ground. And that's equal to 11 meters per second. Now what I'm going to do is I'm going to make east my positive direction, because it's the first one which was told to me. So that's positive 11 meters per second. Now what I've got to do is I've got to say that I've got velocity of B relative to ground. Now velocity of B relative to ground is negative 23 meters per second. Now, what I'm going to show you is a really nice trick. When you're trying to find relative velocities, relative means I'm going to subtract or find the difference between their velocities. So what I need is a way to figure out what's going on here. So I've got B relative to ground, I've got A relative to ground, and I am actually after this. I'm after V of A relative to B. Okay, now here's a bit of a trick that I need to show you. What I'm going to show you now is how to get A's velocity relative to B's velocity. Okay, now the way that this actually works, the reason that I write these letters around is the first object written is the object which is moving. The second object is the observation. Okay, so now somehow I've got to manage to get these to add together. Now the combined velocity of these is a little bit tricky. Now when you want them to add together, you want the ground not to be the factor, because there's no g inside A, B. So how do I get these velocities to speak to each other? How do I find out A's velocity relative to B's velocity? By adding up all these velocities. Now here's your trick when you're trying to get rid of ground. let me show you what I mean. So I've got A relative to ground. So ground is in the observation position. It's in the second position. If you want to get rid of something, you need to be able to put it into both positions. So ground relative to B. Now when I add up these two velocities, so can you see that ground is both in both positions over there? When I add those two up, the ground will cancel itself out because it's in both positions when I add them up. This is because of simultaneous equations. When you add two simultaneous equations and you get a positive and negative term, they cancel out. But without getting too specific, what is A's velocity relative to ground? It is positive 11. Now, the ground's velocity relative to B. Now, you might notice that I've got the wrong velocity here. I've got B relative to ground, which is negative 23. When you switch those two, you change the sign. So that's positive 23. So what we're going to find is that the combined velocity of A relative to B is 11 plus 23. There's a bigger velocity. So A is indeed traveling in the positive direction. So that makes a lot of sense. But it's coming a lot faster than we had planned. It's traveling at positive 34 meters per second. Now, why do I emphasize the positive? Positive means east. Okay, now that was a really long and complicated way of doing things. So now, let's see if our answer is actually in the rest of these. Now, I know, for instance, just using logic, that if I'm sitting in B and watching A travel towards me, because we're traveling in opposite directions towards each other, both of us are contributing towards getting closer much faster. So it's going to look like A is actually coming towards me much quicker than it would. So it's not even vaguely possible for that velocity to be a smaller velocity. Now that cancels out the options A and C. Now, using our very, very important logic, what we know is that A is coming towards us. A is traveling in an eastward direction. Now, we're helping it come towards us, but that's irrelevant. What it's doing is it's adding to the velocity, and this is how we get to our answer, D, 34 meters per second east. So it's A relative to B. But what happens if it was B relative to A? Then option B would be correct. So over here, I was left with D and B. Are the people on the page getting it?
Yeah,
For question 2.2, they're getting option D? Nice, well done, Mansetters. Okay, so a really, really complicated way of doing things. So I've shown you a really long way of doing things, but guys, this is super, super, super reliable. If you start using positive directions in your vectors, you'll get there. I think we've got time for a few more. What do you think, Abby?
I think so too.
Okay, so a couple of really nice short ones. Okay, now the quantity which remains constant, so something which does not change. Okay, for an object falling. Okay, now another projectile motion question. The ground, to the ground is. Okay, now we've got to start to picture what's going on when something falls down to the ground. I start out at a certain position, an object is dropped, and it starts to go down to the ground. It starts out with an initial velocity of 0 meters per second, and then it starts to speed up. I've got an acceleration towards the ground of 9.8 meters per second. I'm just stating some of the facts which I know. So if I make down positive, I've got 9.8 meters per second squared. And that is my acceleration towards the ground. My final velocity is going to be bigger. So we don't know what it's going to be, but it's going to be positive something. All right, now we haven't even begun to look at our answers here. Guys, the answers are there to confuse you if you don't know what you're doing. So best, you draw a diagram, choose a direction, and get yourself organized. Okay, so an object falling towards the ground. Now, is the potential energy remaining the same? Well, I've just got to compare these two objects. So an object up here at point A and point B, which one of them has more potential energy? Well, definitely the one at position A, because potential energy depends on an object's height. The height is changing, guys, so potential energy is not constant. So that was an easy one to cross out. What about kinetic energy? Well, kinetic energy depends on velocity. Is the velocity remaining the same? No, guys, we can cancel that one out as well. Now, this next one is not as easy. Mechanical energy. Oof. This is something that I haven't really seen since grade 10. Guys, mechanical energy is the sum of kinetic energy, EK, or capital K, plus EP. Now the sum of these, now that I'm interested in. The mechanical energy in a system which has no friction actually does remain the same, as long as there's no non-conservative forces. That's a really fancy way of saying the object doesn't lose any of its energy. So mechanical energy, this is a possibility. C might be correct, but let's consider option D. Option D, the object's momentum. Does an object's momentum remain the same as it falls? Well, momentum depends on the mass, and the mass doesn't change. But the velocity increases as it falls. So the momentum can't remain the same. So definitely we are left with option C. Option C, the mechanical energy of this object is going to remain constant. I think I've got time for one short one. I really want to get through one more. Okay, now what they've done, and I've drawn in this picture on the page as well. So it says the above mentioned pattern. Now the pattern that they're looking at, the pattern that you'll be looking at on the page, is all of these light lines and dark lines alternating with each other, nice and evenly spaced. So if you take a look on the page, what you're seeing is light lines and dark lines. So that's a pattern. Now guys, anytime you're getting light lines and dark lines, guys, this is an interference pattern. Now it says equally spaced. Now that's quite important as well. Light and dark bands. The experiment during which this is obtained is called. Okay, well, this is an interference pattern. I know which one I'm looking for, but I want you to think about this, and let's try and find out what's going on here. It's either a single slit or a double slit diffraction experiment. Now, single slit interference is not really an experiment which we did, neither is double. However, the sign that they are equally spaced identifies this as a double slit experiment. That's the only time that you get those nice and evenly spaced answers. Guys, I was a little bit overexcited and I put a whole bunch of questions, but guys, get practicing in the notes. Practice together.
That's very good.
Okay, it was a great show.
It was a great show indeed, and the mindsetters are complaining. They're saying you should add 30 minutes more because they want to learn. But otherwise, thank you very much, guys. Unfortunately, we have to wrap it, and we have to end it here for today. We had a great time ever. Remember, you can still communicate and chat with us over Facebook. We love you, and a big thank you to Macmillan, our proud sponsor, for making this show possible. From me to you, never give up, and peace.